Nearly half a century after leaving Earth, Voyager 1 continues to defy expectations. Launched in 1977, the spacecraft has traveled more than 24 billion kilometers from home, far beyond the planets, through the boundary of the heliosphere, and into interstellar space. It's humanity's most distant and enduring explorer. But in late 2023, something went wrong. The spacecraft stopped sending readable data back to Earth. Its radio signal was still there, a faint, continuous heartbeat traveling more than 22 hours through space to reach NASA's antennas. But what came through was gibberish, a stream of unreadable bits. After nearly 47 years of operation, it seemed possible that Voyager 1 had finally reached the end of its long mission. At the Jet Propulsion Laboratory in California, the engineers who still maintain the probe faced a daunting challenge. Voyager 1 is equipped with 1970s technology, an 8-track data recorder, less memory than a modern digital watch, and no spare parts. Every command takes nearly a day to reach it, and another day for a response to come back. Diagnosing a problem across 24 billion kilometers is a process that requires precision, patience, and a little faith. The problem was eventually traced to a single component, the Flight Data Subsystem, or FDS. This is the computer responsible for organizing the probe's scientific measurements into a stream of data that can be transmitted to Earth. In late 2023, the FDS began sending corrupted data, suggesting that a memory section had failed. The team faced two options, neither simple. They could try to reset the system completely, risking that Voyager 1 might never reboot, or they could attempt to isolate and bypass the damaged memory while keeping the rest of the computer alive. With no physical access, all of this had to be done through careful software commands. By early 2024, NASA engineers began sending a series of small test signals. These were carefully crafted packets designed to probe which parts of the FDS still worked. Because of the enormous communication delay, each test took more than 48 hours to confirm. Over several months, they managed to reroute some of the system's code into unused sections of memory. In March 2024, the first partial success arrived. Voyager 1 began transmitting its engineering status again. Simple information like temperatures and voltages. That was the first sign of life. The spacecraft was still operational. In April 2024, after more than 5 months of troubleshooting, the team successfully restored one of Voyager 1's scientific data streams. Slowly, the full functionality returned. By July, all 4 of its remaining instruments, the magnetometer, plasma wave detector, cosmic ray subsystem, and low-energy charged particle detector, were once again sending back valid data from interstellar space. This recovery was more than a technical repair. It was a lesson in engineering endurance. Voyager 1 was never designed to operate this long. Its systems rely on radioisotope thermoelectric generators, or RTGs, which produce electricity from the natural decay of plutonium-238. Each year, the power output decreases by about 4 watts, forcing engineers to switch off non-essential systems to keep the core instruments alive. Even so, the spacecraft is expected to remain operational until at least 2030, possibly longer if power management continues to succeed. The data it sends back is invaluable. Since crossing the heliopause in 2012, Voyager 1 has been measuring the plasma density of interstellar space, the region where the solar wind no longer dominates. These measurements tell scientists how the Sun interacts with its galactic environment. It's the only probe to have provided direct data from this frontier. What's remarkable is how little the mission has changed since the 1970s. Commands are still written in legacy code, compiled for hardware that no longer exists anywhere else. The Deep Space Network, with massive 70-meter antennas in California, Spain, and Australia, still tracks the signal. One that is now more than 20 billion times weaker than the power of a typical smartphone transmission. Engineers sometimes describe receiving data from Voyager 1 as catching the whisper of a candle flame from across the solar system. The spacecraft itself, though ancient by modern standards, was built with extraordinary care. It carries a suite of instruments that helped redefine our understanding of the outer planets. Detailed images of Jupiter's storms, volcanic eruptions on Io, the intricate rings of Saturn, and the first close-ups of Titan's haze. After completing its planetary encounters, it turned outward and kept going, carrying with it the now famous Golden Record, a time capsule of Earth's sounds and images meant for any intelligent beings who might someday find it. When Voyager 1 re-established full communication in mid-2024, it felt like hearing from a long-lost explorer sending back a final postcard from the edge of the unknown. It reminded the world that exploration doesn't always end with a spectacular moment. Sometimes it endures quietly, sustained by human persistence and problem solving. Today, Voyager 1 continues to send daily data packets to Earth. Each one is a scientific measurement, but also a message. Proof that even a spacecraft built nearly 5 decades ago can still push the boundaries of what's possible. The team at NASA's Jet Propulsion Laboratory continues to monitor both Voyager 1 and its twin, Voyager 2, which is slightly closer to Earth. Eventually, as power levels drop below the operational threshold, both spacecraft will fall silent. Their trajectories, however, will carry them endlessly through the Milky Way, long after the last trace of their radio signals fades. It's estimated that in about 40,000 years, Voyager 1 will pass within 2 light-years of another star system, moving silently through the dark, still carrying the Golden Record. A human signature drifting between the stars. For now, though, it's still talking, still listening, still working. And that's perhaps the most extraordinary part of all.